Interference. So on interference, that's why we're going to talk about a wavefront. A wavefront is a surface of constant A. It's a surface of constant phase. Huygens construction can be used only for all the above and other situation. For light, for electromagnetic wave is one of the media in a vacuum, and for transverse wave, that's Huygens principle. And then number 4, units of optical path length, meter, length, meter. Okay, at the light waves represented by the 3 rays shown in the diagram all have the same frequency, 4,7 wavelength, fit into layers 1, 3,2 wavelength fit into wavelengths fit into layers 2 and 5.3 wavelengths fit into layer 3. Rank the following according to the speed of the waves least to greatest. D 312. Velocity is force multiplied by wavelength. So mathomo ba re ke 4.7, ya bobedi ba re ke 3.2, ya boraro ba re ke 5.3. So ba thomile ka ya boraro o ya ka di-number tsena tšeo ba o fileng tšona. O thoma 5.3, wa ta 4.7, wa ta 3.2. Interference of light is evident that light is a wave phenomenon. Light is a wave phenomenon. The reason there are 2 slits rather than 1 in Young's experiment is to create a path length difference, or the differentiate path. And then in Young's double slit experiment, it's on the experiment of a bright fringe occurs whenever waves from the slits differ in phase by a multiple of what? Multiple of none of the above. Or this one get distance, so you are none of the above. This one define phase by a multiple of 2 pi. I got it. None of the above is not fourth, it's not half, it's wavelength. This one here distance given none of the above. But here you're in phase going to 2 pi, 2 pi to 360. Waves from 2 slits are in phase at the slits and travel to a distant screen to produce the third side maximum of the interference pattern. The difference in the distance traveled by the waves is E, 3 wavelengths. So waves from 2 slits are in phase at the slits and travel to a distant screen to produce the second minimum of the interference pattern. The difference in the distance traveled by the wave is C, 3 halves of a wavelength. Okay, these questions are the same. You should always choose 3 wavelengths. 3 wavelengths of a wavelength. 3 wavelengths. I am okay 3 halves of a wavelength. Ka maximum ke 3 wavelength, but ka minimum is 3 halves of a wavelength. A monochromatic light source illuminates a double slit, and the resulting interference pattern is observed at on a distant screen. Let D equals to center slit spacing, A is equals to individual slit width, D is equals to screen to slit distance, and then L is equal to adjacent dark line spacing and the interference pattern. The wavelength of the light is then A dl divided by D. dl divided by D. Get a lowercase Dennis, let's say, or Dennis. Okay. Light from a small region of an ordinary incandescent bulb is passed through a yellow filter and then serves as the source for a Young's double slit experiment. Which of the following changes will cause the interference pattern to be more closely spaced? The answer is D. Use a blue filter instead of a yellow filter. Shumisha blue, Oscar Shumisha, not yellow. Use blue colors for a police car, not yellow. In a Young doubles experiment, the slit separation is doubled to maintain the same fringe spacing on the screen. The screen to slit distance must be changed to D, which is 2D. Dennis Umbona 2, I 1. In a Young's doubles experiment, light of wavelength 500 nanometer illuminates two slits that are separated by 1 millimeter. The separation between adjacent bright fringes on a screen 5 meters from the slit is B 0.25. 0.25 centimeter. In a Young doubles experiment, the separation difference between the slit in D and the screen is a distance D from the slit. D is much greater than D, and the wavelength is this wavelength of the light. The number of bright fringes per unit width on the screen is E. So E is D over lowercase d divided by uppercase D times lambda. In a Young doubles experiment, the slit separation is doubled. This results in what? A halving of the fringe spacing. So in an experiment 18, in an experiment to measure the wavelength of light using a double slit, it's found that the fringes are too closer to easily count them. To spread out the fringe pattern, one could A. Decrease the slit separation. The phase difference between the two waves that gave rise to a dark spot in a decrease, more like a decrease, slit separation will decrease. The phase difference between the two waves that gave rise to a dark spot in a Young's double slit experiment is E 2 pi m plus pi. So it's 360 plus 180, that's 540. I have it. In a Young's experiment, it is essential that the two beams come original from the same source. Did you also say two from one source? A light wave with an electric field amplitude of EO and a phase constant of 0 is to be combined with one of the following waves. C. Wave C with an amplitude of 2 EO and a phase constant of 0. So I take a 2 EO and then 0, so it's 200. A light wave of with an electric field amplitude of 2 EO and a phase constant of 0 is to be combined with one of the following waves. So the answer is D. Amplitude of 2 EO and then a phase constant of pi. Now it's not going to be 0, it's going to be pi. When does it become pi? It becomes pi when you multiply 2 times E. And you're given, okay. One of the two slits in a Young's experiment is painted over so that it transmits only half the intensity of the other slit. As a result, the dark fringes get brighter and the bright ones get dark. E. J dark diva bright and then J bright diva munyama. So in a Young's double slit experiment, a thin sheet of mica is placed over one of the two slits. As a result, the center of the fringe pattern on the screen shifts by an amount corresponding to 30 dark bands. The wavelength of the light in this experiment is 480 nanometer and the index is index of the mica, it's 1.60. Therefore, what's the correct answer? There 24 hours. The answer is 0.024. 24 hours. Light from a point source X contains only blue and red components. So after passing through a mysterious box, the light falls on a screen. Bright red and blue bands are observed as shown. The box must contain a double slit. Double slit. Binoculars and microscopes are frequently made with coated optics by adding a thin layer of transparent materials to the lens shown as shown. The surface is shown. 1 see constructive interference between 3 and 4. Monochromatic light at normal incidence strikes a thin film in air. If phi denotes the wavelength, in the film, what is the thinnest film in which the deflected light would be maximum? Yeah, the maximum, it's it's pi over 4. Pi over 4. Pi over 4. Maximum. 24 hours. Monochromatic light. Pi over 4. A soap film is illuminated by white light. Here's SIP for 800 nanometer and Sierra 4,0 times 10 to the power of negative 5 centimeter. So red light is viewed through a thin vertical soap film at the thin dark area shown. The thickness of the film in terms of the wavelength within the film is what is E. E is 5 pi. So red light move a stripe, and then a large area first dark area. So answer I wanna give 5 pi over 4. 5 lambda divided by 4. Yellow light. So for yellow light, the film thickness there is much less than the wavelength, or the thick one is less than the wavelength. We can control level loves. Therefore, the 3 experiments involving a thin film in air are shown. If T, if on whatever thing, we have incident light, we have incident light, we have incident light, we have the eye, we have the eye. Therefore, the answer is 1 and 3 only. 1 and 3 only. 5 pi, 5 lambda over 4, and therefore T is equals to 1 over 2. Side and not a liquid refractive index. Okay, liquid refractive index, whatever thing. So Rory it if a inverse more really 3 over 3. So inverse over 3 over 4. Shear light, it hit incident light, it hits air, and therefore coating with glass length. So the answer is 0.28208. In a thin film element experiment, 16th dark fringe, 6th whatever thing, 2400 is closer to 2500. An air wedge is formed from 2 glass plates. We are forming an air wedge. Therefore, the dark bands spread out, disappearing off the left edge. To disappear more left. This one here, an air wedge also. But now we're not going to choose 25, we're going to choose 1,0025. This one ends a glass which is n is equal to 1,6 is coated with a thin film of 1,3 to reduce reflection offsetting incident light. So the least thick film thickness, negative thickness in pi over 4. Yes. Two-point sources vibrating in phase produces an interference pattern with a ripple chunk. If the frequency is increased to 20%, the number of nodal lines you increase by 20%. If two light waves are coherent, their phase difference is constant. The phase difference is this one, is constant. To obtain an observable double slit interference pattern, the light must be coherent. The phase difference sensitive constant. Therefore, 40 light sensitive coherent. constant, 20%, therefore pi over 4, and therefore 1,0025, therefore left edge 2.4, 8 through 0, I don't know, 0, 2008 Cambridge, and inverse. Therefore this one, that's where it's going to pick the right. See, the film thickness there is much less than thickness is less than wavelength. Oh, 5 pi over 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. Oh, it's 5 pi over 4. Over the located white divided by the located black. Therefore, here the answer is what? I would have chose 2,4. The answer is 4. Or I 4. The right of 4. It's 5 pi over 4. Constructive interference between 3 and 4. Therefore, double slit. I would have chose D 0,024. And then and the Juliet challenge. Ronald EO. This one I guess only. Yeah, if this one give A, this one is sensitive to A, therefore A is there. But this one give to A, they is sensitive to A, therefore phase constant distance increase even pi. Come original from the same source. I think I remember most of these things.